Hey guys, my name is Ramon, and I will be talking about an exercise in section 6.1, exercise number 16, in which we have to sketch the graph and also find the area between the two functions. So, we have that our equations are x plus y squared minus 4 is equal to 0, and the other one is x plus y is equal to 2. So, to graph this, we would have to make this to solve for one of the variables, and we would try to make it the easiest way possible. So let's try it for x here. So this one would be x is equal to negative y squared plus 4, and in this one it would be x is equal to negative y plus 2. So now when we graph this, we have plane. And we have that negative y squared. Since it's y, it's like this. It's to the side, it's a sideways parabola. And since it's negative, it goes all the way back to the negative side. So, since it's plus 4, we begin at plus 4. And we go like a parabola. There we go. And x is equal to y, negative y plus 2. So, when y is 0, x is 2. And when x is 0, y is 2. So, and when we graph this line, oops, this one's not really that good. Let's try it again. Graph the line here, and we have that this would be our area. So that's a sketch. So let's see how it would be easier to solve. So when we look at it this way, with respect to x, we see that there is an area that is not included in that region. So we can try to solve it in another way with respect to y, which would be from here to here, and everything is included. So let's do it with respect to y. So we have everything solved for y, and we make them equal to each other, and we solve. So x is equal to, we make this one equal to this one, so it would be negative y squared plus 4 is equal to negative y plus 2, and we solve, so it would be negative y squared plus y, positive 4 minus 2 would be plus 2 is equal to 0. And if we divide this by negative 1, we have y squared minus y minus 2 is equal to 0, and we can factor this, where minus 2 times y plus 1 is equal to 0, and we have that y would be from 2 to negative 1. So this point here would be negative 1, and this point here would be 2. So now that we have our graph, now we can find the area. Since we know that the integral is from 1 to 2, from negative 1 to 2, find that the area is equal to the integral from negative 1 to 2 of the graph on the right side, which is negative y squared plus 4 minus the graph on the right, which is negative y plus 2 of dy. So now we evaluate this integral, which would give us that a is from negative 1, the integral from negative 1 to 2 of negative y squared plus y plus 2 dy. So now when we solve for this integral, we have that negative 1/3 y cubed plus 1/2 y squared plus 2y from negative 1 to 2. And when we evaluate it, we have that 1/3 times 2 cubed plus 1/2 y squared, 2 squared plus 2 times 2 minus 1/3 negative 1 cubed plus 1/2 negative 1 squared plus 2 times negative 1. And when we simplify this, we have that this would be negative 8 cubed, over 3 plus 4 half, which is 2, plus 4 minus negative 1 cubed is negative 1 times negative 1/3 is 1/3. Negative 1 squared is positive 1 times positive 1/2 is 1/2, and 2 times negative 1 is negative 2. And if we keep simplifying, 8/3 minus 1/3 is negative 9/2, 9/3. 2 plus 4 is 6, plus 2 is 8, minus 1/2. And when we simplify this even more, this would be negative 18 plus 48 minus 3 over 6. Right? A would be 30 minus 3, 27 over 6. And this would be our area. Hello there. In this exercise, 6.319, we will sketch the graph and later find the value using the shell method with respect to the x-axis. So to do this, we need to find the formula for that, which is v is equal to the integral from a to b of 2 pi y times f of y times dy. This is with respect to the y-axis. So the first part of this problem is to sketch. So let's do this. Plane. And we have that y is equal to x squared. So this is our graph, a normal parabola. A little bit lower. And then we have that y is equal to x plus 2. So we have our y-intercept, and it's increasing, so we know that it goes like this. So this would be our area that we're trying to find. So this is our sketch. So since it's with respect to the x-axis, we can see that this area right here will not be included when we find the integral of this area. So we have to find the integral from here to here and the integral from here to here. So what we do, first we have to find where these points are. So first we have to find all these equations with respect to x. So this would be x is equal to the square root of y, and here it would be x is equal to y minus 2. So by doing this, and by making them equal to each other, we will find where these two graphs intersect. So let's do that. Square root of y is equal to y minus 2. And we square it, we have y is equal to y squared minus 4x plus 4, and 0 is equal to y squared minus 5x plus 4. And this factorizes equally, so it will be y minus 4, y minus 5, and y will be equal to 4, and y will be equal to, not 5, it's 1, and 1. So we have that our integral will be from 1 to 4. So from here, which is 1, to here, which would be 4. But since, see, from 0 until 1, the graph won't be included in this. So we have to add another part of that integral. So let's just continue here. So we have that our formula is v is equal to the integral from 0 to 1 of 2 pi y times, so here we are using this equation, square root of x, square root of y. But since we know that square root of y is positive and negative, and one side is positive and one side is negative, we can say that this would be equal to 2 to the square times the square root of y times dy. And then we add from 1 to 4. integral from 1 to 4 of, this one's on the right side, so it's the square root of y minus y minus 2. Oh wait, sorry, forgot something. It's 2 pi y times the square root of y minus y minus 2 dy. Now that we have this, we can simplify it. So we have that b is equal to the inner width. We can factor out the 2 pi times 2, so it would be 4 pi times the integral from 0 to 1. We simplify this, which would be y to the 3 halves dy, plus we factor out the 2 pi from the integral from 1 to 4 of y to the 3 halves minus 1 half y squared, 1 half, not 1/3 y cubed. This y times y is y squared, and the integral of y squared is 1/3 y squared, plus 2 times y, which is 2y, and when you get the integral of 2y, it's y squared. So plus y squared. Right? We didn't get the integral yet. We were just simplifying. Sorry about that. So it would be y 3 halves minus y squared plus 2y dy. And now we get the integral of this. So it would be y is equal to 4 pi of this integral, which would be 2/5 y to the 5th half from 0 to 1 plus 2 pi times this integral, which would be 2/5 y to the 5 half minus 1/3 y cubed plus y squared from 1 to 4. And now we just define this integral, so we substitute the values. 4 pi times 2/5, 1 to the 2/5, to the 5 half, and 0 would be 0, so we don't have to do it, time plus 2 pi 2/5, 4 to the 5 half, minus 1/3 times 4 to the cube plus 4 squared minus 2/5, 1 to the 5 half, minus 1/3 y cubed plus, wait, y, we substitute that with 1, and here, 1 squared. And when we evaluate this, we have that this side would be 4 pi times 2/5, which would be the same as 8p5, plus 2 pi times, this would be 32 times 2, 64/5, minus 64/3 plus 16 minus 2/5 plus 1/3 minus 1. And when we keep simplifying, 8 pi 5 plus 2 pi, 64/5 minus 2/5 is 62/5. 64, negative 64 plus 1 is 63/3, and plus 16 minus 1 is plus 15. So when we simplify this, we have that it's 72 pi 5. And that would be our answer.